Hello everyone. Today we are going to discuss about the topic resistance and the other topics resistor, the Ohm's law, the standard color codes, the color bands in a resistor and the resistors in series and at last the resistors in parallel. So let's start. Our first topic is resistance. What is resistance? The opposition that a substance offers to the free flow of electric current in a circuit is known as resistance. We can see the symbol of resistance on the screen. The standard unit of resistance is ohms. We can also see the symbol of ohms on the screen. This is done by an electronic component known as resistor. Our next topic is resistor. A resistor is an electronic component that is deliberately designed to have a specific amount of resistance. Most of the resistors nowadays in the electronic devices is the carbon variety. The resistors values range from less than 1 ohm up to millions of ohms. The unit of resistance is ohms and it is measured by ohm meter. To understand the Ohm's law, we have to know first the three definitions that are current, voltage and resistance in a circuit. As we have discussed the resistance earlier only, so we will now discuss the two topics. First, let us discuss what is current. The current is the flow of free electric charge carriers from one point to another point. These charge carriers can be the electrons or ions or holes. And this electric current is measured in units called ampere. A current of 1 ampere consists of the transfer of 1 coulomb of charge per second. This current can be either alternating current or direct current, and the current is symbolized by the capital letter I in most of the equations. And to know what is voltage, we have to know what is potential difference. 2 points in a circuit are said to have a difference of potential when the electric charge at one point is not the same as the electric charge at the other point. This potential difference is measured in volts. Now let us discuss the Ohm's law. Ohm is the unit of electrical resistance in the meter kilogram second system, named in the honor of the 19th century German physicist Georg Simon Ohm. Ohm's law is a simple relation between the current, voltage and resistance in a circuit. The current, voltage and resistance in a direct current situation are interdependent on each other. If two of the quantities are known, then the third can be found by a simple equation. The amplitude or size of the current that flows in a circuit is directly proportional to the amplitude of the applied EMF, that is electromotive force, and is inversely proportional to the resistance of the circuit. This relationship is known as Ohm's law and it is shown here. That is I equal to V by R. That is current equal to voltage by resistance. We can also write it in this form, V equal to IR. The formula can be restated that V equal to IR and R equal to V by I. Now let's see this example. That is, a heater with a resistance of 10 ohm is connected across 250 volt power line. Then what will be the current? Now we can find the amount of current flowing in a circuit by the Ohm's law. That is, I equal to V by R, we know, where we have been given that V equal to 250 volt and R, that means resistance, is 10 ohm. Then what will be the current? According to the Ohm's law, I equal to V by R. So 250 by 10 A is ampere. The unit of current here will be ampere. So it will be 25 ampere. There are 5 types of resistors. Most of the resistors we use nowadays are carbon resistors. We can see the image of the carbon resistor on the screen. There are other resistors such as the film resistors, we can also see on the screen, and the carbon and metal film resistors, and also the wire wound resistors we can also see on the screen. Here we can see the diagram of a resistor. The resistor consists of 4 bands. First band of brown color, second band of black color, third band of red color, and fourth band of golden color. And the brown color code becomes the first digit, the black color code becomes the second digit, the third color code becomes the multiplier, and the fourth color code becomes the tolerance of the resistor. Here we can see. Now we will discuss the standard color codes and the color bands of a resistor. Here we can see the standard color code chart on the screen. The usefulness of a resistor is measured by its electrical rating. There are 3 factors used to determine this rating, that are the ohmic value, the heat dissipating capability, and the resistance tolerance. The tolerance of a resistor is the variation from the expected value. The ohmic value cannot be recognized by looking at the resistor, so the resistor is labeled by color codes. The resistors usually have their values stamped on them by different color codes. In the resistance color code, the first 2 bands represent the figure of resistance value and the third band represents the multiplying factor. And at last, the fourth band represents the tolerance of the resistor. Now, we have the color code chart on the screen. Now, let us study the chart. In this chart, we can see there are the colors that are black, brown, red, orange, yellow, green, blue, violet, grey, white, gold, silver, and no color. And they all have numbers from 0 to 9. From black to white, 0 to 9 numbers are there in the first band and the second band. And also in the third band, similarly, the multipliers are given from black to blue. That are 10 to the power 0 for black, 10 to the power 1 for brown, 10 to the power 2 for red, 10 to the power 3 for orange, 10 to the power 4 for yellow, 10 to the power 5 for green, 10 to the power 6 for blue. And also the multiplier for gold and silver, that is 0.1 for gold and 0.01 for silver, and there is no number for no color. Similarly, in first band and second band, gold, silver and no color have no digits. And in the fourth band, we can see that black have no tolerance and brown have plus minus 1% tolerance, red have plus minus 2% tolerance, orange have plus minus 3% tolerance, yellow have plus minus 4% tolerance, green have plus minus 5% tolerance. And after green, blue, violet, grey have no tolerance. Similarly, white have also no tolerance. There is plus minus 5% tolerance for gold, plus minus 10% tolerance for silver, and plus minus 20% tolerance for no color. So we have studied this color code chart. Now let's see the examples. Now let's take this first example. Here in this resistor, in the first band we have yellow color, and according to the color code chart we have 4 in yellow. So 4 will be the first digit of this resistor. In the second band we have violet color, and according to the color code chart violet is 7. Similarly 7 will be the second digit of this resistor. In the third band we have orange, and according to the color code chart orange is 10 cube, that is 10 to the power 3, as it is the multiplier, that is 3 zeros. So this will be the multiplier of this resistor. And in the last and fourth band we have silver color. According to the color code chart, silver is plus minus 10%, that is the tolerance of this resistor. Therefore the resistance is 47,000 ohms plus minus 10%. Here 10% is the tolerance of this resistor, and this is the symbol of ohms. Now let's see another example. Now let's take the example of this resistor. In this resistor, in the first band we have brown color, and according to the color code chart brown is 1. So the first digit of this resistor will be 1. Similarly in the second band we have black color, and according to the color code chart we have 0 in black. So 0 will be the second digit of this resistor, and as the third band is the multiplier of this resistor and we have red color, and according to the color code chart red is 10 square, that is 10 to the power 2, that is 2 zeros, and it will be the multiplier of this resistor. And as the fourth band is the tolerance of this resistor, we have gold color here, and according to the color code chart gold is plus minus 5%, that is the tolerance of this resistor. So therefore the resistance of this resistor is 1000 ohms plus minus 5%. Here plus minus 5% is the tolerance of this resistor, and this is the symbol of ohms. Now let's see the clay model. So we have discussed about the two diagrams of the resistors, and I have made the clay model for the second diagram's resistor. This is representing the resistor of the second diagram, which is having the 4 bands. Brown, which is representing 1, black is representing 0, red is representing 10 squared, 10 to the power 2, that is 2 zeros, as it is the multiplier, and fourth band gold is representing plus minus 5% tolerance, and this model is representing 1000 ohms plus minus 5% tolerance as its resistance. Let's come to our next topic, that is resistors in series and resistors in parallel. We can see the images of the resistors in series and resistors in parallel on the screen. So let's discuss these topics now. Resistors in series. In series resistance circuit, the total applied voltage is divided across each resistor and the current flowing in each resistor remains same. Let us take the example like such that the total resistance of a series resistance circuit is given by R total equals to resistance 1 plus resistance 2 plus resistance 3, and we can simply add up to the resistance to the n power. In series resistance, we have to just simply add all the resistance. Now let's see the example which is coming on the screen. Example coming on the screen is the 3 resistors of 5, 5 and 10 respectively are connected in series with 80 volt applied voltage. Find the current in each resistor. On the screen we can see the diagram of the series resistance. The R1 is 5 ohm, the R2 is 5 ohm and R3 is 10 ohm respectively. And our DC source, that is the direct current source, is 80 volt. So as we know, we can simply add the resistors which are in series. So we will just add the R1 plus R2 plus R3, and that 3 addition is RT, that is R total. That will be 5 plus 5 plus 10 equals to 20 ohm. And for the finding the current in each resistor, we will use the Ohm's law, that is I equal to V by R. We know that will be 80 by 20 and the answer will be 4. So the current remains same in the series circuit, that is 4 amperes. Current flows through the each resistor is 4 amperes. So we can understand by this example about the resistors in series. Now our last topic is resistors in parallel. In parallel circuit, the applied voltage remains same across each branch, but the current is divided among the branches. Total resistance of a circuit when resistors are connected in parallel can be given by 1 by R total equal to 1 by R1 plus 1 by R2 plus 1 by R3 and up to the nth term. Let us see one example. We can see the diagram of the resistors in parallel on the screen. Now let's see the example. 3 resistances of 5 ohms, 10 ohms, 30 ohms respectively are connected in parallel. When 30 volt is the applied volts, then what is the total resistance and total current? We can see that 1 by RT equal to 1 by 5 plus 1 by 10 plus 1 by 30, because we have already seen that to find the total resistance of a circuit in a resistor in parallel, we have to do 1 by R1 plus 1 by R2 plus 1 by R3 up to the nth term. Similarly, we have done 1 by 5 plus 1 by 10 plus 1 by 30. Then the R total is 3 ohm. Therefore, the total resistance of the circuit is 3 ohm. And the RT, that is 3 ohm, and volt is given 30 volt. So using the Ohm's law, I total equal to V by RT equals to 30 by 3, that is 10 ampere. Then the total current flowing in the circuit is 10 ampere. So we have discussed all of our topics. I hope you all will enjoy this video. Till then, everyone be safe and thank you.